All right, we're going to go ahead and complete lesson module 3, homework 4 now. This is taking this, the square roots, cubic roots, and all these different radical forms and now doing operations with them. So we're going to look at still breaking down the structure of radicals so that they kind of match. Now we want, in order to add radicals, they have to match perfectly. The radicals have to match perfectly in order to add their coefficients, just like variables. When we add variables, this is the same thing with radicals. They have to match. So when we're looking at first question and we have to add this all together, we don't even start looking at anything collectively. We look at it individually. So what I do is like look at 18. I see it as 9 times 2. So 9 times 2, I know 9 is the perfect square of 3. So I take 3 and multiply it against the 2 that's on the outside and put 3 times 2 is 6 and leave the square root of 2 inside. Remember, I don't really want to write this down as much. It should be practiced now, but for the sake of those who are still confused, we're taking perfect squares out. Excuse me, not 18. Excuse me. 9. 9 is a perfect square, and that's why we pulled it out as 3, and then there was a 2 here, so it becomes like this, and that's where the 6 comes from. All right, so I'm going to try to avoid, for the smaller ones, I'm going to try to avoid doing this writing all the time. Now, for this problem, for the next one, see, now that's the individual. Now I'm looking at the next one. I'm just looking at the negative 4 and the square root of 294. Now, I have no idea what 294, I don't have a clue about that one. I know it's not a perfect square. So I'm going to take 294 and see what happens if I divide it by 2 right away. And it comes up with 174. Now, I know that 174 isn't a perfect square. So I'm going to go ahead now and start dividing 294 by my perfect squares. I just want to test that out because it makes sure that it doesn't match this guy. So I'm going to take 294 and divide it by my next perfect square is 9. It's 3 times 3. That doesn't work. 294 divided by my next perfect square, which is 16. That doesn't work. See, so I'm looking at 294. I know 25 or 5 is not going to go in, or 25 is not going to go in, so I'm not even going to do that one. So I'm going to do 36, and it's not working. So 294 divided by 49, and that works. So I love it. I don't even worry about whether or not I knew that 49 times that, or I'm not starting to sit here and break it down and all this stuff. I'm going after my perfect squares, and I see 49 is a perfect square, and it comes out as 7. So once I know that, then 7 times 4 is 28, and then I leave the 6 inside the radical system. If that's not a perfect example of how to break down a radical system, there's nothing else that's better. This one was one that was very intimidating. It was a high number. I was grabbing my perfect squares and waiting until it lands in a nice, good number. And if it doesn't, then it's not. There's no perfect squares in it. And that's kind of rare with a number like that. Now, 50. 50 is 25 times 2. I think we know our quarters. So 25 is 5. 5 times 1 is 5. And I'm left with 2 in the radical system. 6 is a perfect, there's nothing in it. It's 2 times 3. There's all primes. You can't take anything out of it. So it's going to be left alone. Now, in doing all this, we are going to see that in commonality, you're going to have things that match. Like the square root of 6 and the square root of 6, they match. If I was so bold to make assumptions, I would have taken the square root, I would have taken 6 and divided it into 294 right away and see that it went into it 49 times rather than doing this. However, I wanted to show that this was a pure example of just taking your perfect squares and dividing it. I kind of wanted to do that on purpose to show you that I'm not afraid of it. I'm just going after my perfect squares. So these match and these match. Now, once these match, the 6 plus the 5 gives me 11 radical 2, and then I have negative 28 minus 5. So negative 28 minus 5 is negative 30, and then you got like 33 because obviously 5 plus 28, and then we have the radical of 6. Now these cannot be added together because they do not match. You can't break them down anymore. We're not multiplying them, we're subtracting them. So it's not going to work. So that's our answer, and we leave it as such. All right, so there's what we came up with. Now let's go ahead and look at number 2. So this process is time consuming, but it is not impossible. So just take a chill and just do it. All right, so 128, we can start looking at it as division by 9 because obviously 9 can go into it, and that's a perfect square. But then when we look at this, it's 4 times 5. See, so when I break this down, I take 180. If I don't like doing it this way, the way I did this one right here, the 294 one, I can take 180 and I can go ahead and break it down to 9 times 20 is 180, and I can take 4 times 5 is 20. And then when I go ahead and write that down, I'm going to have the square root of, and I'm not going to do the 1. The 1's ridiculous. I couldn't write down, but what is the sense of writing a 1 in front of anything? It's just itself. But anyway, I'm going to put 9 times 5, 4 times 5. So 180 is this, right? So what's the square root of 3? It's going, excuse me, square root of 9 is 3. So 3 comes out as well as a 2 comes out. So 2 times 3 is 6. So right now, I know that 6 squared is 36. If I took 180, and divided it by 36, it would have came out with 5. See, so I showed you another alternative way of finding it without getting so worked up about if you can't find the perfect square right away. So you have that. And now I'm going to go ahead and look around. I'm going to see that, okay, the 28 is 4 times 7. So I'm going to go ahead and put down 2 times 5 is 10. And then I'm going to have the 7 inside. And what threw me a bone, I mean, this literally threw me a bone. I saw the 7, the radical 7 right here, and I saw that this is 4 times 7, so I knew that this is going to be the answer, that it was going to be 4 times 7. And then the 4 comes out as radical 4 is 2. 2 times 5 is 10. That's where the 10 came from. And I know that you can re-watch this, so it's kind of nice that you have that ability to re-watch. So if I'm going too fast, you can slow it down. So the 45 is 9 times 5. All right, that's what 45 is. So I'm going to go ahead and take out 3, leave the 5 in, and then I'm going to look at negative 2 times radical 7. So now I'm going to combine these two together and combine these two together. 6 minus 3 is going to be 3 radical 5. And then negative 10 minus 2 is negative 12 radical 7. Notice how I never do anything with the radicals. Once I find them that they match, they're just the coefficients are what I deal with. So that's that one. Now, number 3, it says completely simplify. Now, again, we're looking at simplifying this right here. So let's write it down first. What this is testing us is the fact that this, just because these are the same, the indexes are not. So since the indexes are not the same, we do not touch this one with these two. But these have the same index and the same number, therefore negative 9 minus 2 is a negative 11, radical 3, and then plus 8, third root of 3. And we do not bring those together. This is why this is having it done all together. Now, when we're looking at the next one, same ideas and principles follow through, is that we make sure that we are combining only like terms together. 14 is 7 times 2. Those are both fine. You can't simplify that any further, so we're done with that one. We can't do anything with it. So when we look at this, only these two match. So then -4 minus 1 is -5, radical 7, and then -8, radical 14. Okay? Now, when they put parentheses around this, it's to indicate that they want to do distributive property kind of stuff. Because there's no multiplication here. All right, so what I'm going to do is distribute the negative signs of both things. I'm going to get -7, +9, radical 2. And now this is going to go ahead and tell me that I have 5 plus 9 is going to give me 14, radical 2. And then I have -8 plus -7 is -15. Of course, you can go ahead and put it -15 first. However, this is not incorrect. So the idea here is to get them to match if they can and to bring them together. That's the idea. You should be catching on to that. From here, we're going to break it down again. This one it has 4 times 5. This one has 9 times 5. So if you do enough of these, you can catch on really quick. So this is -16, 5x, and then this is going to be 3 times 3 is 9, 5x. These are the same. Now it's going to be -25 times 5x. All right. Now -5. So I see that at 4 radical 7. I'm immediately going to take 112 and divide it by 7. I mean, I'm serious. I don't even want to deal with it until I know that that works or doesn't. So there it is, a perfect match. That's a perfect square. So the reason it flagged me is because I saw that we have radical 7 here. Why not try then that, right? So 112 broke down to 16 times 7. And so I can take 16 out as 4. 4 times 10 is 40. So I'm going to go ahead and put this. And then I have my answer as -36 radical 7. All right, let's keep on going, trucking along. So we have the root of 32. I see that as 16 times 2. All right. All right, now we're going to go ahead and look at it. I'm going to show you this. I'm going to break this down a little further. Watch this. 16 times 2, and then x times 2 times x. And then this is going to be 25 times 2, and then x to the square times x. Now, by writing it that way, we know we can see the perfect square. Every time I do it, I'm mainly doing it verbally with you guys, but this, if you're not comfortable doing it verbally, you can do it written down. A lot of times I just write things down to them mentally. I can do it real quick, but 4 comes out as a 16, so it's 4 times 8 is 32. All right. Yeah. And then we're going to go ahead and do x comes out as 1. And then I'm going to have what's left over is the 2x. And then I have 25. The 5 comes out as 2 times 5. And then I'm going to take out the x squared is x. And then I'm going to have left over 2x. Now, I am double underlining what needs to match now. The variable this time, along with the radical and everything inside the radical, have to match. So everything has to match before we deal with the coefficients in front of it. So the coefficients in front of it, 32 and -10, minus the 10 to 32 gives it 22 x radical 2x. All right. I like getting the right answers. All right, number 7. Now, when you're doing enough of these, some students complain that, oh my God, there's too many homework problems, too many homework problems. You know what? Until you can do it as fast mentally as I'm doing it on some of these, then you haven't done enough problems. Because you should be able to do this so quick. And I'm being honest when I say I can do most of this, like a lot of this, I should say, in my head. I mean, I don't even need to write anything down, but that's not teaching. That's just me doing. So, 28. All right, I don't know what 28 to break down to. I don't know anything about what this can break down to. So I'm going to go ahead and take my calculator. 28 divided by 4. Let's see what happens. 28. I can break it down. 10 to 7. So that's 4 times 7. All right, and then the R can come out. As a matter of fact, write this down as the R coming out. All right. All right, now when I take 252, I'm going to take 252 and divide it by 7, see what happens. 252 divided by 7, that gives me 36. Wow, 36. Okay, that's a perfect square. So and what prompted me to use 7 as my divisor is that I went ahead and saw that this was 7. So I'm going to go ahead and break down 36 times 7. Now I have 112. Well, I'm going to see what's 112 divided by 7. Does that work? It does. 16 times 7 is 112. So that's a magic number because 16 is a perfect square. So I'm going to go ahead and take 16 times 7. And then the R I'm going to bring out in front of it. I'm going to bring that R in front of it. I don't need the R squared in here. So now I have perfect squares along with this radical 7 all these times. So now 4 taken out is 2, is 2 times 2 is 4. R radical 7. And then 36 is 6. 6 times 7 is 42. And then R radical 7. And then 16 is 4. 4 times 6 is 24. R radical 7. And now I've cleaned it up to the point where all this is the same. All right? Oh, of course. Doing it in your head is hard, guys. I mean, it's not that easy. I'm not saying it is. I got a lot to teach you, so I go fast. So, 42 minus 24 is 18 plus 4, and that's going to give us 22. I'm kind of just doing it on a calculator, right? Whatever. So we have 22 R radical 7. Oh, good. I forgot that question, right? If I meet going fast with you, and you guys are attempting to keep up, what am I doing to your synapses right now? Firing them up, and I'm making you think real quick. I'm inspiring you to think fast. They are firing off. I love it. Love it, love it, love it. All right. Now, when I look at this, okay, I'm taking the cubic root. Now, the cubic root of 27 is 3. So I can go ahead and get this. Now, I don't have common denominators, but I do have the same radical systems, so I need the common denominators to be the same. So 21. So what I'm going to do is I'm going to put 7 over 21 here. I am now changing my number, and I'm going to put 3, 21 over here. And then 7 minus 3 is 4. Radical 6, excuse me, it's not just radical 6, it's third root of 6. And then all over 27. And then that's the answer we're looking for. Is it 27? No, it's 21. 21. I couldn't read it because I was writing over my junk. 21. All right, so that's my answer. All right. I would have gotten that wrong if I didn't check over. And that, that's the disadvantage of rewriting over because I saw the 7 and it made me think that 27, but I knew it wasn't 27. So it's going to 27. All right. Yes, it does, Brian, but 7 doesn't go into 27. All right. Now 9. Let's do number 9. All right. Now we're doing multiplication. All right. So this is interesting. So let's look at this operation. I got a strategy for you on this one. All right. Whenever you multiply radical against itself, the contents of the absolute value, or not absolute value, the contents of the radical comes out of the radical. So I don't need to go ahead. You should know that radical x times radical x actually equals radical x squared. So when I multiply these together, what the radical of x squared is simply x. So that's what I mean by whenever I multiply a radical against itself, it will come out, the contents of the radical will come out of the radical. So then it's simply as this. 4 times 4 is 16, and then radical x times radical x is x. I don't need to go ahead and write it like this. Do not do that. All right? Please do not write that. And that's just going to make more work for yourself. Now, when I multiply this times this, it's going to be 4 times negative 5 is going to be negative 20, but then it's radical x times radical y is going to give me radical xy. Now I'm going to go ahead and multiply these together. I'm going to get positive 20 xy, and then I'm going to go ahead and multiply these together. I'm going to get negative 25 y. Now, I'm going to go ahead and recognize that these are opposite of each other. And since these are opposite of each other, they can cancel each other. And that leaves me with 16x minus 25y. Now, I'm going to also highlight a particular thing about this. That these are actually the same exact things except for their opposite signs. And when we're looking at something like that, it's the difference of 2 squares. And if that's the case, the difference of 2 squares, I can literally take and square this term and square this term and put a minus sign between them, and I have my answer. So I could have, if I identified that, rather than doing the foiling process, which is okay, I could have recognized that right in the beginning and been able to proceed through this quicker than just going ahead and writing every single thing down like so many of you do. You do not want to choose to learn a particular formula, and that is that a plus b times a minus b is simply a squared minus b squared. So many students refuse to want to learn that, and then they make themselves a lot more work. So that's my lecture, and I'm telling you, I'm, I'm scolding you if you're not remembering these things. So now, square root of 5 plus square root of 3, square root of 5 plus 20. Now these are not the same. This has a 20, this is 11. So, and also, these are also not different squares anyway. So now we got 5 times 5, they're both in radicals, so it's going to become 5. Now, radical 5 times 20, radical 3 is going to be plus 20 radical 15. And then I'm going to go ahead and get this one, it's going to be plus radical 15. And then I'm going to go ahead and multiply these together, and it's going to give me 20 times 3 is 60. Because I'm going to have these multiply against each other, and the 3 is going to come out. Multiply against that 20 gives me the 60. Now, this means I can bring this together. Gives me 65. All right. 65, and bring these together, it gives me 21 radical 15. By the way, here's the answers. All right. Man, I love it when a good thing comes together. All right. Now, with number 11, this is the difference between two squares. And because the difference of two squares, the difference of two squares, I'm going to practice it. My answer is 25, okay, minus 7. So my answer is, I don't know, what is, that's going to be 20, or excuse me, 17, or 18, excuse me. See, when you know your difference of two squares, you don't have to multiply it all out. That's the significance of that. Now the next thing is right here, a perfect square. I'm going to try to help you remember this. A little bit more challenging to try to do all this, but it's not really. If you go ahead and follow this formula, square root of 5 times square root of 5 is 5, but that's going to be, when we're dealing with a squared. Multiplying them together is going to give us radical 15 doubled is going to give us negative. By the way, this is the negative, so I'm going to erase these two symbols. Negative, I'm going to put minus sign. And then I'm going to get 2 times radical 15. And then I'm going to go ahead and square the last term, and it's going to give me plus 9. So these two add together gives me 14. And then this is 2 radical 15. I'm done. There's my answer. Where in the heck did I get the 14? That's not right. Let me see what I did wrong. Okay, I'm going to say, I know that this is recorded, but can my class who I'm working with tell me what did I do wrong? Write it down. I have no patience. So did anybody catch it yet? What's the square root of 3 squared, or the square root of 3? What is that squared? All right. Not 30. 3, right? I went ahead and, because I'm so used to doing regular square rooting or squaring something, I squared 3 and that's 9, but I should have put 3, right? And then that would change my answer. 5 times, or 5 plus 3 is 8. All right? So that's what I did wrong. I went ahead and squared 3 rather than squared radical 3. And I'm glad I made that mistake because sometimes when we're using this formula, we want to be careful with the fact that it's in a radical system. I love this. This is good stuff. All right, 13. It's difference of two squares again. So what I'm going to get is 25 times 2 is 50. And then I'm going to get minus 16 times 7. Now, I don't know what 16 times 7 is off the top of my head. 16 times 7 is 112. And then take 112 minus 50 from it, and that gives us negative 62. So that's the power of using the difference of two squares. And you've got to realize that these are the same exact things. They're opposite signs, so we don't have to FOIL all out. And now I just go ahead and take square of both 5x squared, or x, or excuse me, square root of 2. And then I'll get, that's where the 25 comes from, 25 times 2. So anyway, I'll go ahead and do the difference of squares. It moves this very, very quickly. Now, when I'm looking at this one, I'm going to go ahead and look at this as -6 radical 2. And then I'm going to look at this as this multiplies against the 2. It comes out of the radical. So it's going to be 3 times 2 is 6. And we can rewrite this a little bit as just 6 minus 6 radical 2. Okay, I could write it this way, which I wrote. I prefer it written this way myself. Now the next one follows in suit to the next last one. Is it's going to be 3 radical 11, and then it's going to be plus 11, and we can leave it as that. Now this is when you want to FOIL. Now this times this is going to give us x. This times this is going to give us negative 8 radical x. This times this is going to give us 9 radical x. This times this is going to give us negative 72. I can combine these two together, but I can't combine anything else together. So I can write it as this. Well, you know what I'm going to do? I'll write the radical. I'll put the constant by itself first, or at the end of it. So I'm going to put plus, because negative 8 plus 9 is 1. And then I'm going to go ahead and get negative 72. How we order it, it doesn't matter much. It will give you the right answer. However, constants only go at the end, just like any other system. So we just leave it as such. All right, we're almost done. So number 17. Article 63. Now, as I mentioned before, you want to break things down before going ahead and approaching these things. So what I'm going to tell you is like, I know that when I look at this, right, 63 is divisible by 9, all right? So what I can do is say that this is 3 radical 7. 50 is 25 times 2, or 5 radical 2. So I can break it down in smaller radicals first, before approaching this any further. And then 175, take 175 divided by 25, gives us 7, right? So this is going to be 5 radical 7. And then 48, take 48 and divide it by 16, and that gives us 3. So then this is going to be 4 radical 3. So I'm breaking them down by perfect squares, and now I have it in simpler form. I can go ahead and proceed to multiply them out now. Okay, that's the best approach, is to simplify it first before these big numbers get involved. So now I go ahead and multiply this out. This is going to be 15 times 7, right? 3 times 5 is 15. And then you have radical 7 times radical 7 is just 7. So it's 15 times 7. And that gives me 105. So right now what I'm doing is FOILing. So this times this, now this times that. I have 3 times 4. 3 times 4 is 12. 7 times 3 is 21 in the radical. Then I have this times this is going to give me 25. Radical 14, because that's all that is. And then I'm going to go ahead and multiply this times this. Gives me 20. Radical 6. All right, so then now I look at all this, nothing combined together, so then this is going to be a long answer, and as we have it, that is the answer I give you right now. All right, that's exactly what it gave you. Now, I know I'm cooking, I'm moving. I mean, some of you are probably thinking, I can never do it that fast. Yes, you can. Stop doubting yourself. You just haven't practiced enough. You can do it. If I can do it, you can do it. That's the way I look at it. Don't think, oh, man, because you're a dog, you can do anything. No, I can't. I'm a human being. I'm kind of like, I'm not a computer. I'm not a calculator. I'm just a human. And you are too. So you just got to get more practice. That's all. Now, this time this is going to give us x. This time this is going to give us negative 6x squared. This is going to give us negative radical x. This is going to give us positive 6. Now, we're going to go ahead and bring these two together. And that's the only two we can bring together. These are the only two that are like each other. So we're going to get negative 7 radical x plus 6. And that is the answer we're looking for. And the last and final question for today, right? We have 5 radical 1 times 3 radical x. Now, when we look at this, we multiply this out, we're going to get 15 radical x y to the 4th, and then we're going to get 5 radical y to the 4th, y times y to the 3rd is y to the 4th. Now the y to the 4th come out as y to the 2nd radical x, and then this comes out as y to the 2nd, and there's our answer. Because you can't combine it together. All right. So that concludes our homework for Module 3, homework 4, as well as for